Now that we can iterate through each character in the source code and skip whitespace, let's extend the Lexer to recognize symbols such as colon, equal, and plus. These symbols are key components of our language, and we need to handle them specifically. At the top of the Lexer class, we define a dictionary called symbol map, which maps certain symbols in the source code, like colon, equal, and plus, to their corresponding token types, colon, assign, plus. This map allows us to quickly look up a symbol's type whenever we encounter one. Inside the tokenize method, we've added a check to see if the current character is a symbol defined in the symbol map. For example, if the current character is colon, we first check to see if it is defined in the symbol map. Since it is defined, we will look up the token type in the symbol map dictionary, which will return colon type. We then create a token with this type and the value of the symbol. Here's what the output looks like after running this code. As you can see, the symbols colon, equal, and plus are correctly recognized and printed as tokens with their corresponding types. However, when dealing with letters such as main, result, and return, we see that they are processed one character at a time. While each individual character is not a symbol, together, these characters form meaningful names such as function names, variables, or keywords. To make sense of these sequences, we need to combine certain characters into meaningful names. Here's how we can do it in the code. Let's walk through an example to illustrate. Suppose we're processing this line of code. The Lexer starts at the first character R. The loop checks. Is R a symbol or white space? No. Good. We have start pos set to the index of R. We will illustrate why we need to do this later. The Lexer then reads E, S, U, L, T. Once it reaches the space before the equal character, the loop stops as shown in this condition. At this point, the Lexer has captured the sequence result, and it knows this is a meaningful name. You may find we have another condition here. This is in case where there is no space between the name and the symbol, like this. The Lexer still starts at R and moves through the characters E, S, U, L, T. This time, the loop stops as soon as the Lexer encounters the equal symbol directly after T. In this case, the Lexer captures the name result before processing the equal symbol. Once we reach the end of the name, we extract the text with this line. This gives us the complete name. In programming languages, some words have special meanings. For example, return is a keyword that tells the program to return a value. Other words, like result and main, are variables or function names that store or represent data. Here's how we modify the tokenize method to handle this. We'll first check whether a given name matches any known keyword like return. If it does, we'll classify it as a keyword. Otherwise, we'll treat it as a variable, which could be either a variable name or function name. However, we also need to handle numbers. In our case, 5 and 3 are integers. To detect if the captured text is a number, we can simply check if the string contains only digits using the isDigit method. As you can see, the Lexer now correctly identifies integers, symbols, and the return keyword. Finally, instead of just printing the tokens, let's store them in a list and return them. Why do we do this? Storing the tokens allows us to use them in the next stages of compilation, like parsing and code generation. By returning the tokens, we can hand them off to other components that will need them later. Now, we can print all tokens outside Lexer. We also want to add a new line token. Why is that? New lines play an important role in many programming languages, as they signify the end of a block of code. By explicitly recognizing and storing new lines as tokens, we can maintain the structure of the code and ensure the next stages of compilation handle the code correctly. In this lecture, we've completed the Lexer by adding the ability to recognize names, keywords, and integers alongside symbols. In the next steps, we'll continue building by introducing parsing and generating code from these tokens.